Welcome back to my channel. Today we'll be discussing on how to diagnose electric scooter battery. So normally you realize your electric scooter battery, you just start up the scooter and it doesn't turn on. You think it's fuse, you check on the fuse, there's no issue with the fuse. Now majority of those faults are caused by the cells themselves. So sometimes some of the cells have higher internal resistance, which means they are damaged, so they don't allow current to flow through it. So this pack is an example. Now this pack is a 38 volts battery, so let's test the terminals to find out the voltage. So my multimeter has been set to DC. Now let's test the probes. So from testing the probes, you can see the voltage I'm getting is 24 volts, which is bad because when this battery is low, the lowest voltage should be 29 volts. So since it's displaying 24 volts, that means there's an issue with some of the cells. And there are two main methods of checking. Now you can check them by testing it from the connectors which is coming to the BMS, which is this portion here. So you put your positive probe here, which is the first positive one. So you put your positive probe there from the multimeter, then you move. So from here you are supposed to get the voltage from the positive to this part, 3.8 volts. Then there should be a 3.8 volts difference between each of the terminals. So the point where you get 0 is where the issue is from. So let's start. So here now I'm getting 7 volts. Let's go 6 volts, 4 volts, 1, 0, 6, 9, 11, 13. So you can see that there is a major issue with this battery. So now what I'll be doing is I'll dismantle the whole pack and I'll be running capacity test on them with the help of this capacity tester. So as you can see, there are some cells already running inside. So I'll show you how to go about it. But please, before you carry out any operation like this, make sure you have the technical know-how, or else these cells can cause fire. So mishandling them is very dangerous. Now let's proceed. So I'll have to dismantle the whole pack. So let me do that and get back to you. Now let me cut the lines going to the BMS first. So I'll cut the wires first. This side is done. Let's proceed to this side. So now the BMS has been taken off. So let's proceed with the cells. These batteries are highly explosive material, so make sure you have idea before working on them. You can see what I'm talking about. So make sure you have a good idea about them, or else they can cause fires, which is very dangerous. So the configuration of this battery is 4 series 10 parallel, which gives about 10.4 amp hours, 38 volts. So now you can see this is the 4 parallel, and they are 10. So 1 2 3 4 5 6 7 8 9 10. So this is it. Now there are 2 ways to run the test. It's neither running them in packs like this or separating them to check them like how these cells are being checked. If I was to run it in pack, then I'll have to solder wires to both the positive end and the negative end and connect it to this portion here. You can see this portion here and run the test on it. But with that, the result is not as promised, because when you run the test and all cells have the same capacity, then you are to get the rating on the case of the pack. So let me get the case of the pack so you understand what I'm talking about. So this is how the case looks like, and you can see it's 10.4 amp hours by 36 volts. Sorry, not 38. So now if you were to run the test on each pack, you are to get 10.4 AH by 3.8 volts or 4.2 volts. So if it's less, which means some of the cells have gone bad inside, but that's not always the best option. So the best option is to run them individually, like how I'm doing with this. So let me go ahead and separate them, then I'll run the test individually so we can proceed with what I was talking about. Now this is how this capacity tester works. You can see the indication here: mAh, mWh, mR. So the mAh is for the milliamp hours, which is the capacity, and the mWh is for the milliwatt hours, and the mR is for the internal resistance. Now the V here stands for volts for the cells, and the A is the current, which works when you are charging the cell. So now how this device tests the capacity is it charges the battery and discharges it. So you can either test the capacity by charging it or by discharging it, or by using auto mode, which charges and discharges at the same time. Not at the same time, but I mean it will charge it and discharge it. Then you will get the results instead of just charging or just discharging. So now I'll separate the cells. Now the reason why I want to test them 4 is to identify the particular pack which has the issue. So now these 4 sets will go in first. After testing, I'll leave an inscription on it. So it will be something like this. You see, something like this, which shows the capacity and the internal resistance I got, which will help me to troubleshoot the actual fault very well. So let me just dismantle this one. So let me take the nickel plates off. Please be careful when handling stuffs like this. As I told you earlier, they are very, very dangerous. Especially this portion here. So now that the pack has been separated into 4 different cells, let's go ahead and slot it into the tester. So put the first one. Okay. That's okay. Put the second one. That's okay. Put the 4th one. Now the normal here, which is the 4, is for these sections here. So here is 1, 2, 3, 4. So currently it's showing the info for this particular cell, and you can see, let's forget about the capacity here because it's the capacity for the cells that I was checking earlier. So now let me change to the first one. Now you can see the first one, the internal resistance is 66, the second one is 68, the third one is 63, and the fourth one is 57. So now I need the voltage to be around 4.2 volts. Then I'll have to discharge it to 2.5 volts to check the cell. So let me change it to charge. So now I'm charging the fourth one. I'm charging the first one. I'm charging the second one. I'm also charging the third one now. Now the lights blinking indicates that the cells are undergoing a certain process. Now you can see that they stop blinking after a while, which means they are refusing to charge to their actual full voltage, which is the 4.2 volts. So let's go ahead and discharge the cells to see. So let's change it to discharge for the 3 and 4. Let me change the 4 to the 3 to discharge. So now you can see whilst this discharging them, this is the current it's drawing from the cells now, and this is the voltage. So you can see the information has been reset, both the milliamp hours and the milliwatt hours, but the internal resistance stays the same. And this time here shows the time taken to calculate the cells, the capacity of the cells. So let's go ahead. So we have to leave it a while. It normally takes about 2 to 3 hours to fully check the capacity. So let's just leave it for some time and come back to check. So after running the test on the cells, these are the results I got. You can see that the one with the lowest internal resistance had the highest capacity, which is 1000 mAh. Now look at the rest. You see. So which means the capacity of the cell has degraded, because the actual rating was supposed to be 2500 milliamp hours per cell, and as you can see, some are not even giving up to 1000. So which means that majority of the cells have gone bad. So I'll do same for all of these. So this is the result for the second batch. So this was the first one I tested, the one I showed you earlier. So with the second one, you can see that the voltage section displays 00, even though the cell has been placed in their appropriate positions. Now the reason being that their internal resistance are very high, so there is nothing which can be done about them. So these are the main causes of the voltage drop in the cell. These are the causes of the main voltage drop in the cell. So this cell has short the actual voltage, which is the 36 volts, by let's say 3.8 volts. So that's the cause of the battery failure. So this is the second batch I'm testing now, and the internal resistance of all are high. So there's nothing which can be done about it. So I'll test the other ones to see. Let me take the cells out. Okay. I need to place a mark on them to indicate that they are damaged. I'll take a different pack. Now you realize because this cell is working, as soon as I insert it inside, the voltage pops up. Now let's see. So now their cell is not full, it's not up to the full voltage, so I'll now have to use the charging method first for it to get to the full voltage before discharging it to test the capacity. So I'll pause for now and return when the test has been fully completed. And you can see with this one, the internal resistance is a bit different from the first one. You can see this one 89, 55, 70, 70. So normally when you get the internal resistance like this, it's advisable to replace the whole pack, because with the results like this, it shows that the battery has been used for a long time. So most of the cells are closer to their lifespan, the end of their lifespan. So this is how it works. So in order not to waste much time, that's how to diagnose or test your battery to identify the damaged ones. And if not for the results I'm getting so far and the internal resistance were to be stable, then I would have to just replace the cells which are damaged from inside. But since the internal resistance are not the same, there's nothing which can be done about it. So I just have to build a new pack for the customer. So that's all for today. See you on my next one, and please don't forget to subscribe and like my videos. And also, if you don't understand anything, just leave a comment. I'll be quick to help you out. That's all for today. Bye.